Pluto had it coming from the beginning. It was never really belonged Pluto's orbit. Crosses that of another planet that's no kind of behavior for a planet. Pluto, the mysterious dwarf planet at the edge of our solar system, is causing a stir in the astronomical community. Recent reports suggest a possible impending collision with Neptune, sparking concerns among scientists and space enthusiasts. Renowned experts including Neil deGrasse Tyson and Michio Kaku have raised alarms about the potential consequences of this celestial clash. But how exactly did Pluto find itself on a collision course with its distant neighbor? And what could this cosmic collision mean for our existence on Earth? Join us as we explore the mystery of Pluto's potential collision with Neptune. From orbital mechanics to gravitational tugs, we will unravel the mysteries of this cosmic event. Pluto was first classified as a planet, but due to its unusual orbit, it was eventually reduced to the status of a dwarf planet. Even after being downgraded, Pluto continues to captivate the astronomy world. Astronomers have discovered a lot about Pluto in the years since its discovery in 1930. It's turned out to be a very unusual object. When it is closest to the Sun, it emits a thin atmosphere and is very reflective. It also has a family of satellites, one of which is the massive Charon, which is slightly larger than half of Pluto at a diameter of just over 1,200 kilometers. Renowned scientists such as expert Michio Kaku and Neil deGrasse Tyson have issued warnings about the alarming closeness of Pluto's asteroid path to Neptune's. These renowned physicists warn of an impending collision. How is such an event even possible? Pluto's journey around the Sun is unlike any other planet in our solar system. It takes a staggering 248 years to complete a single orbit, meaning since its discovery in 1930, it hasn't even finished one full revolution. There's more mystery ahead. Pluto's orbit is defined by an extremely elliptical form, which deviates greatly from the larger planet's nearly circular orbits. What makes Pluto's orbit even more peculiar is its inclination. Pluto's trajectory is significantly steeper than that of the other planets, with an angle of 17 degrees to the ecliptic plane. Its circular shape and inclination give its orbital pattern additional layers of complexity. One notable aspect of Pluto's orbit is where it intersects with Neptune's path. Every now and then, for about 20 years in each orbit, Pluto actually comes closer to the Sun than Neptune, which is contrary to predictions made based on their relative positions in the solar system. This raises the question, why hasn't the much-feared collision between Pluto and Neptune happened yet? The answer can be found in the gravitational patterns of other celestial bodies. Examined since its discovery, Pluto's orbital path reveals an intricate path to scientists. As opposed to its planetary members whose orbits primarily align with the ecliptic plane, Pluto's unique characteristics include an elliptical shape and a steep inclination. The mystery grows as Pluto's and Neptune's orbits collide. Pluto's trajectory remains stable in the face of numerous convolutions, demonstrating the complexity of celestial mechanics. Space's three-body problem, which analyzes the motion and gravitational interactions of planets like Pluto, Neptune, and the Sun, is where the cosmic triangle problem is revealed. This mystery mimics the accurate tracking of their paths according to starting locations and reciprocal gravitational poles. It explains the intricate interactions between Pluto's trajectory, Neptune's journey, and the Sun's gravitational pull. The solution to the three-body problem reveals the complex gravitational forces forming the orbits of these objects, which advances our knowledge of Pluto, the solar system, and other far-off cosmic companions. According to numerical models conducted in the late 1980s, Pluto's orbit is technically chaotic, with small variations in initial conditions resulting in large variations over millions of years. Despite these stable features, nonetheless, it has been shown that these distinct characteristics of Pluto's orbit maintain stability over extraordinarily long timescales, thereby containing the chaos. New simulations have improved our understanding of how major planets such as Neptune, Jupiter, and Saturn impact Pluto's orbit around the Sun. Neptune and Pluto share a unique bond. The phenomenon known as mean motion libration explains why Pluto is always at least 90 degrees apart from Neptune as it crosses its orbit latitude. Libration, on the other hand, makes sure that Pluto is always far above the solar system's plane and Neptune or any other huge planet when it approaches them. These two things work together to keep Pluto safe. Scientists using computer simulations discovered that Neptune, unsurprisingly, has the biggest impact on Pluto's azimuthal libration. This is due to the two planets' 3:2 orbital resonance, which states that Pluto rounds the Sun exactly twice for every 3 times Neptune does. Pluto's trajectory is maintained by this connection. Not everyone is as helpful as Neptune, though. Pluto's orbit is kept secure and steady, in large part, by Jupiter's gravity. Also, Saturn contributes a little. These tests demonstrate that Pluto can be kept on a steady course for billions of years or more simply by the force of Jupiter's gravity alone. It seems that Neptune, Jupiter, and Saturn work together to ensure that Pluto continues to travel through space safely and trouble-free. For space bodies to continue moving in an orderly and predictable manner, certain events are necessary for maintaining the cosmos. The solar system, as we know it, would be far more chaotic and unpredictable without these systems. It is possible for bodies such as Pluto to crash with one another or to be thrown off path. Speculating about cosmic events is hard work, especially when it comes to planets like Pluto that have unusual orbits. Because these systems are inherently unpredictable, making long-term predictions is a risky undertaking. Numerical simulations provide means to understand and predict the future motion of asteroids. But because these models rely on exact initial circumstances and simulate complex interactions, they reveal the limits of our prediction power. The turbulent character of planetary orbits, as Pluto's illustrates, is an important reminder of the always-changing nature of the universe. Even with these complex interactions, renowned physicists are beginning to express concerns regarding a potential collision between Pluto and Neptune. This begs the question of whether such a collision is possible, considering the complex dynamics at work. Renowned physicist Neil deGrasse Tyson, who played a key role in Pluto's reclassification, offers a distinctive viewpoint on the mysteries that exist in our own solar system. Tyson, who is well known for his ability to make astronomy more accessible, views Pluto's reclassification as a necessary update that is in line with our growing understanding of the cosmos. He sees Pluto's orbit and its intricacies as a reminder of how much more there is to learn about space exploration. Tyson thinks that astronomy is so interesting because of the fascination of these mysteries. Events such as Pluto's reclassification and peculiar orbit, in his opinion, present chances to pique people's interest in the cosmos. He provides an opportunity for the general public to be amazed by the mysteries and wonders of the cosmos. By talking about the dynamic and occasionally counterintuitive parts of space physics, Tyson is actively warning the public about the possible threat of Pluto's erratic journey. While collaborating with other scientists, he believes that a collision with Neptune is long overdue and has expressed fears that the three-body dilemma may actually be a threat. After researching Pluto in great detail, he further highlights how such a collision could disrupt the delicate equilibrium in our solar system. A collision between Pluto and Neptune would be disastrous. The crash with Neptune would cause a shock wave that would exceed anyone's imagination and may cause the surface to slightly warm up. Because of its tiny size and mostly frozen composition, Pluto would probably shatter apart in this encounter, releasing a large quantity of energy. The collision's debris may disperse throughout the solar system, endangering nearby planets and their moons. Given our distance from the outer solar system, the immediate impact on Earth would be minimal, but the scientific implications could be significant. From a powerful telescope, the impact would be amazing. It would even temporarily raise Neptune's brightness over the point at which it can be seen with the unaided eye from Earth, making it appear like a very faint star in our sky. Like Tyson, Michio Kaku talked about the possible collision and connected it to his universe theories. It would be an important astrophysical event, providing a special chance for observations that might further our knowledge of string theory. The goal of string theory is to explain the fundamental forces and matter in the universe by replacing one-dimensional strings for point-like particles in a theoretical framework. Such a collision might produce extremely high gravity and energy levels in the solar system. Furthermore, the collision's gravitational waves could provide important information for evaluating string theory's gravity and space-time predictions. TRAPPIST-1. The gravitational attraction of the 7 Earth-sized planets produces a repetitive pattern known as orbital resonances. Planetary pathways may become less stable over time as a result of these patterns, possibly resulting in collisions in systems such as TRAPPIST-1. There is currently no collision, despite their crowded nature. Scientists keep a careful eye on these systems to learn how planets affect one another's trajectories, especially when they are close. Frequent collisions are prevented by the vastness of interstellar distances and the relative rarity of planets in free space. While the collision is awe-inspiring from a cosmic perspective, its effects on our solar system and Earth remain a cause for concern. We must continue to study and understand this extraordinary event to safeguard our planet and unravel the mysteries of the universe. I hope you enjoyed this video. Don't forget to hit the like button and subscribe to our channel for more interesting space-related content. Thank you very much for watching, and I will see you in the next video.